Oh, okay.
Okay, what? And then two of those two.
Just a 1, 2, 3, 4.
We need two. So if we get two here and then 2, 3, 1, 3 here and 1, 2, 2 times 3 gonna be 6, and then 1, 2 gonna be 6.
Alright guys, let's take a look here.
Okay. You will have, yeah.
There's another reason I like method 1 is because, guys, when you break it down to parts, you start to look at it the wrong way. You say, well, how do I know what goes where? And that happens a lot. Does the 5 go outside or inside? And there really should be no question about what gets left inside. It's either the poor little dude I can't do the root of, or it's the poor little dude that there's only one of or not enough of, right? So I'm going to do some of these both ways. So if I use method 2 on this, I would break 50 down into 5 times 5 times 2, right? So which one of these can I do?
5.
Yeah, so outside I would write a 5, and inside is left the poor little 2. But it does get to a point where you're just like, how do I know which number comes out? But it's not the right way to look at it. It's you do the square root of what you can do, and that's, of course, whichever one has enough. In this case, has 2 things in it, right? So since there's 2 5s, I can put 1 5 outside. Yes, sir?
So if there's 3 5s, you leave 1 5 inside?
Beautiful. Exactly. So my way of doing this, this is the second method. Here's the first method. Would just be to break this up as 25 times 2. Square root of 25 is 5. The square root of 2 is, I don't know. And there's a little less ambiguity about how do I know which one is where, because it doesn't even come down. The only reason there's a 5 is because I took the square root of 25. Right? So it's a little bit more obvious what's where. I am trying to push you in that direction, but if this makes more sense, beautiful. It's perfectly valid. So what about square root of 72?
9 times 8.
I'm gonna, yeah, good. So I'm gonna do it in a couple steps. Method 2, you would actually break it all the way down, right? So what would you get? How are we doing so far? So that's method 2. So what can you put out front?
3.
A 3 and a 2. And what gets left inside? This poor little 2, because there's only one of him, right? And what's the operation of everything that I'm bringing out? It's multiplication, right? Because I'm factoring stuff. That's why I multiply the parts that I bring out. So this be 6 rad 2. If I do it the other way, this is 36 times 2. Square root of 36 is 6. Square root of 2 is, I don't know. Okay, good. Okay, good. So let's see, number 3. Square root of 120. Oh my God. So if you do method 1, break this all the way down, it'll be like 12 times 10. What do you get?
6, 2, 5, 2.
Yeah, you get 2 times 3 times 2, right? Times 2 times 5. So what is there 2 of?
2.
Yeah, those 2 2s. So I can put a 2 out front. And there's not 2 of anything else. So all this stuff gets left inside. And what is that? 3 times 2 times 5 is? 30. That looks too big. You're like, I should be able to do that. No, you know you can't, because 30 is made of 1 3, 1 2, and 1 5. So you can't do the square root of any piece of 30, right? Yes, ma'am.
For number 2, how do you get 6?
So 2 ways. I took out 1 3, because there were 2 3s, and 1 2, because there were 2 2s. 3 times 2 is 6. Because it's all based on multiplication, right? So whatever I pull out, I multiply them.
I thought it was 32.
Oh, yeah, no. Sorry. All right, how are we doing? And the other way to do this would be 120 is 4 times 30. Square root of 4 is 2. Square root of 30 is, I don't know. Bam. All right, cool. Is that so far so good? I'm still not going to have poker night with any of you. All right. So let's see, number
My
4.
daughter is laughing when you do something stupid in poker. So she was the worst. Poker person.
I have worse burglaries. So if you did method number 2 on this, 8 times 10, so 2 times 2 times 2, times 2 times 5, right? So what is there 2 of?
2. So 2 squared?
Good, so I can pull out a 2 and another 2, and what gets left inside? 5. 4 square root of 5.
What if I left it 2 squared, square root of 5 on the test? Would that be okay or no?
Technically, no. I won't take points up probably, but you don't leave 2 squared because you know it's 4. Does that make sense? Just always at the end, just make sure you simplify everything. I mean, if you leave 10 over 15, I might take a point off or something. At the end, you simplify what you get. And of course, the other way would just be, now watch this. If I saw 4, if I said, okay, this is square root of 4 times 20, square root of 4 is 2. Square root of 20, I don't know, but then 20 is 4 times 5, right? So then square root of 4 is 2. I still get 4 and 5 at the end. It's sort of like reducing a fraction. You don't have to do it in one step. You can do it in multiple steps, right? You just do what you see, and then you see a smaller number. Then it's easier to handle that. Just don't stop too early. Make sure that this guy can't go further. How are we feeling so far? To me, this is very much like reducing a fraction. That's why I call it reducing the radical. It's almost the same kind of idea in a way. Number 5. Oh yeah. What do you think about this one?
I think it's done.
Yeah. All right. Square root of Lambert. Square root of 33. You can't. If there's 3 times 11. It's not 2 of anything. No, I'm done. Now we finally get to some cube roots. Cube root of 64, of course, is just 4. Because 4 cubed is 64, right? So it's one of those you should know. You got to know some of your cubes, some of your squares, some of your 4th powers even. What about cube root of 40? Again, if you do method 2, you break it all the way down. 4 times 10, 2 times 2 times 2 times 5. What are you looking for now? What is there 3 of? There's 3 2s. You can, to represent these, you take a 2 out, and what's left inside the 5. Me, I would say cube root of 40 is cube root of 8 times 5. Cube root of 8 is 2. Cube root of 5 is, I don't know. So either way you do it, thank God you end up at the same answer. Okay, cool. All right. I think we just did this one, didn't we?
Yeah, this wasn't given.
Yeah, this is 27 times 2. This should be 3 cube root of 2, right?
Yep.
We did that one earlier. It's one of my favorites. So what about number 9? This is one that my method definitely wins out. Because I don't have to factor all this. I can see a perfect cube. Of course, that is...
1. 3 times 29.
That's 8, right? 8 is a perfect cube. So I can break this up as 8 times whatever. Of course, it's 111. Right?
Oh,
Now, what about 111? Is that divisible by anything?
no.
What's 1 plus 1 plus 1? So it should be divisible by 3.
3 times 37.
Yeah, and is 37 anything good?
No.
No, so I don't even have to go down that way. Do you guys see what I'm saying? But you do have to take a second and make sure, can this guy go any further? Not really. It can, but it's not 3 of anything, right?
2 times 4.
So what's the cube root of 8? 2. Cube root of 111? I don't know.
This is a completely other way, but got the same answer.
How'd you do it?
I divided 888 by 3 first.
Okay.
and then that's 3 times 2, 96, and then the 296 divided by 2 is 2 times 1, 48, and then always divided by 2 until you get a triple of, yeah, it takes longer, but, and then you see the
So
twos.
then you can see 3 2s.
Yeah.
Nothing wrong with it. This is method 2. This is perfect. I love it.
And you
See the
multiply
3
3
2s,
times
and that's why 2
37.
comes out. And then what's left is 3 and 37, which of course we just figured out is 111. So
We're
either way you want to do it,
overthinkers.
works beautiful. I love it. Okay. Cool. And then the last dude, what's true about this last dude? 100 is 10 times 10 is 5 times 2 times 5 times 2. Is it 3 of anything? No. So, already simplified. Just circle it. Don't write nothing, because then I'll be worried that you didn't even know what to try.
We'll just write oil.
Huh? Yeah, put
Yeah.
oil.
Oh,
Oil. Put already simplified. That's how you spell already simplified. A-L-R. Okay. So any questions on that type of? And I wanted to focus on that a little bit because that's a building block for a few sections coming up. Is understanding this. So kind of doing what we're doing here a little bit backwards. What do you notice about that? What can I do with that?
Multiply them together.
Yeah, why am I allowed to multiply them together?
Because they have the same.
Same root. So then I get cube root of 8 is multiplying, right? Which is?
No, but he's not going to let us use calculators.
And why does it make sense? Cube root of 4 by itself. Why couldn't I do that? Because there's only how many what's in there? There's only 2 2's. So do you see if I give it one more 2? Of course it's doable now. This idea is going to become very important. Very, very, very soon. Maybe. So something that's not quite that clean cut, but still works in some ways. What you got, Jeff? Cube root of 6 times cube root of 9. This is an old standby here, right? When you multiply those together, you get cube root of 54, which we've done enough now. We should all kind of memorize this. 54 is 27 times 2, right? So now this is, cube root of 27 is 3. Cube root of 2, I don't know. Oh, why does it make sense? How many 3's are in 6? 1, right? So 2 times 3. And there's 2 more 3's. So of course I end up with a 3 outside, because overall I'm going to end up with 3 3's. You guys see how it still kind of filled itself in?
Yeah, and
A little too much, so you had some extra left.
for the test, can you just skip the 3 times 9 and put the 54 there? Can you just be like, do method, what is it, 2?
Oh yeah, and just start breaking them up.
Yeah.
I love it. It's even better. That kicks ass. So yes, this is my answer. Okay, cool. All right. So before I get into new stuff, any leftover problem areas, homework questions? Hopefully everybody's at least into 12.1. What's happening tomorrow? Quiz on 12.1, 12.2, 12.3. That's how far we got yesterday.
I guess I just need to go to tutoring. I totally just don't even get this.
12, 2, 12, 3.
Give me something to work on though. Like what?
The whole worksheet. I don't know. I'm just brain dead. I guess I can't figure it out.
12, 3.
So I like the analogy that if I had 9 fists, I can't divide 9 by 5, but I can divide part of 9 by 5. So then I can break up 9 as 5 and 4. 5 divided by 5 is 1. 4 divided by 5, I don't know. So I do the part I can, and I leave over 5 the part that I can't do. So that's exactly what we're doing with something like this. We're saying I can't do the cube root of 16. But I can do the cube root of a piece of 16. Alright, so what's the cube root of 8? 2. What's the cube root of 2? I don't know. It's exactly the same as this. You break up the problem into a part you can do and a part you really can't. You leave the part you can't and you do the part you can. So here 16 is too much. It's twice what I could do. So I write that down. I say, okay, it's part I can do, and I do it, and it's part that I can't do, and it gets left behind. So it's simplifying, it's rewriting radical. So to be honest, it's more like writing a radical in mixed notation, right? But I still like to call this reducing my radical. Yeah.
I don't get how that works though, because it's 5 plus 4, and you can.
Totally. So this is 5 over 5 plus 4 over 5, because they're both being divided by 5. You're right. And are you guys cool with, wouldn't this be the same thing as 1/5 of 5 plus 4? Are those the same thing? Because this is like 1 over 5. And then what would you do with the 1/5? Distribute it. As long as both are divided by 5, it's golden. And I don't know if anybody sees the analogy between that and this. It's the exact same idea. Break it up into a part you can do it. A part you can't do, don't do it. Yeah.
If you, this question goes along the lines of example I. If you were to divide the cube root of 4 divided by the cube root of 2.
Yes. Good.
Yeah,
That's the next section. That's section 12, whatever it is next. 12.5? Yeah. 12.4.
Would there ever be different square roots? I mean, like 1 square root and 1 cube
Same
root?
thing we saw with multiplication. But then we wouldn't be able to divide it unless we'll get there. Okay, I like that. It's a good natural question. We're just talking about multiplying, so now we're going to talk about dividing. It's the next section. It's crazy. So I always want you guys to understand fully why things work. It sounds to me like at least most of us have a grasp on the mechanics of it. So if there's some roadblocks, you can always come see me. You can go see a tutor. Yeah. Unless you have some specific questions that I can kind of work off of. So getting into division. This is section 12.4. So on one level, it should be expected. I can't divide radicals unless they are the same root, right? The same index is the official name of it. So for example, if I had 4th root of x to the 7th divided by the 4th root of x to the 3rd, don't tear your hair out trying to work with that by itself. You could actually do what? Yeah, they have the same root, right? So I can write this as one big-ass 4th root. I can write that like that if you want to. And then the inside is simple.
You subtract.
Yeah, now you're dividing, so when you divide things with powers, you subtract the powers. I like it. So you get 4th root of x to the 4th, which is x. Good. Absolute value officially, but at this point they pretty much always say everything's positive. Just you want to get the ideas down. You'd slap an absolute value in the real world if you had to. But that should make total sense. It's got to be the same root to divide or multiply. I like it. So in that sense, there's nothing really new here. Let's do one more of these with a little more stuff going on. All right, try that one. Simplify that. The mistake people make is they try to work with the top and the bottom separately. That's crazy. You can do it, but oh my God, it's ugly. Alright, so let's see. This is a beautiful thing about this. Since they have the same root, you can sort of ignore the root for a second, right? It's still there. But what is 18 divided by 2? 9. What happens with the D's?
Subtract.
And where is there some left? Good. So how many extra down there? 4. And how many x's are left where? 8 up top. And then you have the square root still there, right? So since they have the same root, you can just divide the insides so they'll all be under one big ass square root if you want to write it like that, right? And we know, from the beginning we knew we could do that. What's the square root of 4/9?
2/3.
Because you know you can split it up. So if I have them separate, I can make it one big ass root and keep going on the inside if I need to.
What happened to the 2 at the bottom?
18 divided by 2. That's where the 9 comes from.
Are we still, it's still 3.
So now you can do the square root. This will be 3.
Okay, good.
Yeah, it's going out.
E squared. Yeah, right? Is that cool? Just cut everybody in half. You guys see that? So each of those, disgusting, mess, gross. 2 goes into 9 4 times with 1 left over. I don't want to do that. If I divide first, ooh, that's nice. Everything's beautiful. Right, doesn't always happen, but this probably did. No. Yes. All right. Let's do a fifth root. Oh.
128. X. Let's do 11. Yeah. And the Y. 207.
Yeah, that's yummy. I like it. Not a normal adjective for a math problem.
Above the Y.
207. I love how you can almost automatically give up when you see a slightly large number. Come on. You do this.
Would you be able to use a calculator to solve like this?
Probably not. You both had the same expressions on your face. You went. The only part of this problem that you should need to maybe think you need a calculator is on the y part, right? Maybe? That would be the only part you need. I mean, you're like, no, that's the only part you would need. No, I wouldn't. Mm-mm. But come on now, 128 divided by 4, easy.
32.
Divided by 4, it's a 5.
Divided by 4.
Oh.
32.
What are you guys doing? If you're doing this and trying to do that, I agree with you. That's disgusting. Why would you do that? Why would you do that? I'm going to do what I'm allowed to do to make the numbers I'm working with easier. And since these are the same
Did you
root,
want this?
what am I allowed to do?
Say yes.
Simplify. Yeah, reduce. Divide.
So normally when you have there's like
Why
a square
two?
root and then
Oh.
like minus
32.
8 and then you cut it
Oh
in
wait,
half,
you subtracted them, right?
So if it's
Here,
a 5
and then-
now, do
You
you
cut it in 5
It's
parts.
like that.
divide the
And
190
then
by
what
5?
did you do after that?
Or you
No, well, yes, exactly. Good. A 190
And
power
it's going to be.
divided by 5. I like it.
divide by
Because
5.
this
love it.
one is big.
This-
This one.
Kick ass.
Yeah, but it's not negative.
Oh,
It's just
this
5.
is 11.
Where does
It's
that
not like in the previous season.
So all going up. We don't have any.
Actually,
well,
this
I
one is.
canceled those
Oh
out,
yeah,
so I'm
both
getting
of them are.
32x,
Yeah.
but then I've got.
I
Wait,
can't
what's
see.
the fifth root of
11. I thought
32?
it's 4.
All right.
The fifth root of
okay.
each of these, right?
All right.
Okay, so it's
Okay.
just numerator.
So is this right, John? I mean, is
So let's see. What's the first step here? The fifth root of, what's 128 divided by 4?
32.
X to the
5th.
X
Fifth.
and then is 190.
Right. So I'll do part of this for you. There, I get an X there, right? All right. See, I did a whole part of this.
Where you do the easy part.
Oh well, too bad. What we should know by now what the fifth root of 32 is.
2.
We've seen that enough, right? So it takes 5 2's to multiply by 32. That part's easy. And now, so this is what I was saying. The only part you should feel maybe what? 5 goes into 200. How many times?
10.
5 goes into 200 40 times. Stay with me now. How many 5s below 200 is this? Is 2 5s below 200, so it's 38. Or just on this, if this is on the part you're not allowed to use calculators, you just go over there. But you can always go 5 to 1. 5 under 200 is easy, it's 40. I need 2 less 5s into the number I want, so that's 38. So inside would be y to the, oops, outside here is, was there anything left?
No.
No, so I don't need it. Because the fifth root of that was easy, the fifth root of that was easy, the 5 goes on 190 evenly, so nothing left inside the fifth root. That's the crazy thing you guys are trying to do on each of these individually. That's I told you. No, I can simplify first. And then maybe it's going to be easy. I'm not going to guarantee it's going to be easy, but at least it would. Maybe I'd have like a 191 there, so I'd have 1 y left inside, but who cares? It's a lot easier than trying to do each of these separately. Crap.
Yeah.
So to go to a question I had earlier, what would you do? I gave you this here.
Can you get a common?
You
Can't do anything because the roots aren't the same, right?
Change it to y.
But the bases are the same, so I can't
Oh,
do
you
one
just
thing.
you just keep it, and then you start subtracting.
Change it into exponents, right?
So it's x.
Wait, you can't.
Oh.
Can you ever subtract like fractions?
Hell no. Say again, sorry?
Nothing.
Since these aren't the
Hell no. Okay.
since these aren't the same,
Yeah.
then I
But you
can't do
can-
anything directly with
I
this.
know, but it's like
Oh,
you can't
there's a
subtract
4?
them like the normal.
I can't do like we did
You
there.
can't do like 7 minus 4, right?
Totally not. Right.
But you could change it into fractions then, right?
But I can change it into this form. And just take what you said. If you thought maybe you could do that, then you should be able to do it here. What's 5 minus 5?
0.
And what's a 0th root? Holy crap. What does it take none of to make 7? I'm not really sure what that means. 7. There was nothing there before. So that's one reason why you can't do that, is because it wouldn't make any sense in that case. But another reason you can't do that is because you can only do something if they're the same root.
And then can
So
you
now
do it
what?
and then
So now what does math say wants to have happen between these powers?
Denominator has to be the same.
Subtract them, right? When you divide like bases, you subtract the powers. Don't let the fact that there are fractions there mess you up. There are two separate things. There's the process, and then there's the actual what's in there. So what does math say about something to a power and the same thing to a power? Subtract when you divide, right? That's what math says, period. Math doesn't care what the hell's up there. Now we care what's up there because I'm like, oh shit, I got to get an LCD. So there's the idea of division of things with powers and like bases. You always subtract the powers. Then whatever the powers are, oh shit, do I need LCD? Do I need something else? What is it?
you just multiply kind of across, knowing that.
Sort of.
Is that-
This is where you could. Cross multiplication only works in one place.
It's equal.
When they're equal.
And there's an equal.
But what I do is if these don't share anything, then it is 12 minus 7 over 28. That is a nice little shortcut. If you don't understand quite why it works, never do it.
No,
Right? It's sort of like don't even use your blinker if you're not used to it, because then you leave it on and you drive me crazy. Right? So
Is that 528?
it's just simpler. What is the LCD?
28.
So then you need to multiply this by 4, and you multiply this by 7, and that's why this sort of works.
12 minus
Because they each need each other, so it is sort of, but then people do that wrong. And, right. So it's just the same as always. So what's 12 minus 7
5.
over
28.
Done. Right? Or if they said, bring it back to a radical form, what would that look like?
The 28 root.
Why?
You guess. Depending on if they say to have it a certain way. If they don't, you can just stop there. They could be me.
It's radical form, the name,
Say again?
radical form,
Yes, so this is radical form,
and the first one is what?
exponential form.
Explanation.
Because again, you know, math people are very creative.
It's got exponents. Call it exponents. It's a cup with dirt in it.
Brian Regan? Brian Regan? No?
Yeah.
Yes, okay. Sorry. The rest of you too, after you.
Wait, that purple thing that has nothing to do with that black.
That was left over, I'm
Okay,
sorry.
okay,
Yeah.
I was like-
That was left over. How's your math class going? I don't know, he's talking about cups of dirt. Google it. It's a cup with dirt in it.
It's on YouTube
Yeah,
right now.
it's a cup with dirt in it. Look it up. Let's see. All right, so that's not really anything new. Once you know you have to have the same root to multiply, division is just really multiplication of the same thing. So it needs the same thing. It has to have the same root to divide. If it doesn't have the same root but has the same base, then we do have kind of a way around it, right? We can make LCD then. And again, once we make an LCD, then we're making both roots 28. We're kind of like building them up. So then we're making it the same root, which division requires. So the only real new thing in this section is related to this. Let me get you guys to help me out here. If I had the cube root of a, and I'm going to let you multiply it by something so that I can do it. Why can't I do the cube root of a?
Because there's only one.
There's only one a in there. What can I multiply by then so that I could do it?
A squared.
And how do you mean? Be very specific. So you mean multiply by a squared?
That's what-
No, cube.
No, you mean multiply by cube root of a squared. Because I couldn't even do it if it wasn't the same root, right?
Yeah.
So you gave me this, and of course, what do you end up with here?
A.
Yeah, a. Cube root of a cubed? A.
Wait, I'm lost.
Sorry. So I started with this, and I said, I'm going to let you multiply by something that will allow me to do the cube root. Right now, I can't do the cube root. Why? There's only one a inside. The minute you say that, you go, oh, well, how many more a's does it need then? 2. So I would multiply by the cube root. I'd give it the 2 a's the poor little dude is missing, if I was allowed to multiply by whatever. You guys with me?
Okay.
Does that make sense?
And you have to do it by the cube root of a squared so that the roots are the same.
So the roots are the same, so then I could do the next step to get to just a. So if I had the 18th root of m to the 11th, what would you multiply by?
The 18th root of m to the 7th.
Do you see that? Because why can't I do the 18th root of m to the 11th? Because there's only 11 m's. There's supposed to be 18 of them, right? So I would multiply by the 18th root of m to the 7th.
Is that a legal move? Like in
Now, I'm with you. This is I'm not allowed to just multiply out of nowhere. I love it. It's a beautiful question. As a math teacher, I'm allowed to say, I'm letting you do that, right?
Will you have a question like that on the test?
Yes, here we go. And it'll be totally legal. So here's the idea. What we're doing now is called rationalization. It's not psychology class, so not that kind of rationalization. The root of this is rational. It's actually ratio, but I want to make the bottom. So what's kind of gross about this? What's kind of gross about this is not only is it irrational, but it's also irrational on the bottom. It's like double gross. So what we want to do is we want to make the bottom not irrational. We want to make the bottom no roots. Now do you understand why I was doing that?
Yeah.
Why am I allowed to multiply this by something as long as I...
To the top.
There you go. I love that question though. You're perfect. You're not allowed to just multiply by whatever. But here, what do I multiply, of course? We already talked about it.
Cube
Root of a square.
Because it's a cube root, I need 2 more a's to make it doable. Whatever I do to the bottom, I better. So I'll do the top. Yay, Jeff. Yeah. So 1 times that is there. And the bottom, of course, comes out to be A. We filled it. We completed it all.
Is that done then?
Okay.
That's done.
So for the test, if you asked a question like that, we would have to get the answer like that.
No, I would never ask a question like that. That was just me focusing on what was important. Does that make sense? Giving it what it's missing. Because that's all this is. And I make the mistake, this is the first time I've taught this starting with cube roots. Because when I show you square roots, everybody always thinks, oh, just multiply by what it is, and we're good. And what do I mean by that? See, if it's a cube root, you need to end up with 3 things, don't you? If it was an 18th root, you better end up with 18 things. Well, if it's a square root, this problem becomes very simple. What do I have to multiply by?
Y.
Another y. But if I show people this first, then they multiply everything by itself. That doesn't make sense for cube roots, right? Square roots it does. Because now you're going to end up with 2 of those things, right? But if it's a cube root, oh, you better end up with 3 things, not just 2. Yes, ma'am?
Why is that rationalization though? Like, should you not have that on the bottom or something? Is
Exactly.
that
It's and sometimes there are situations where we rationalize the top. So the homework will say rationalize the denominator, rationalize the numerator. But in general, it's convention to not end up with a radical on the bottom.
So it's like simplifying.
It's simplification. Yeah. It's how we divide radicals when I can't do like we were doing earlier, where things just cancel out, right? I can't do 1 divided by the. Can I do anything here? No, but this is kind of like the way we do it.
So we don't want to end up with
a radical on the bottom. We want to rationalize the bottom, which means make it rational, not irrational. What makes something irrational?
you can't do it.
They're insane. No, it's a root. So I want to kill the root. So I call this completing the root. Do you guys see what I mean? If it's a cube root, it needs 3 things. So I give it what makes it complete. Yes?
Why'd you do that for number 2?
What do you mean?
Why'd you times it times the...
Why can't I not do the square root of y? Because there's only
Yeah, I thought that was
1 y.
And I thought
Oh, I'm
it was
sorry.
gonna be like
Yeah.
1/2.
It's a y.
Okay, that makes sense
You should do the loop on the bottom.
No, I'm not going to do it. So then what do you get here? Yeah.
Thank you.
And real quick, what's the square root of 11.7 times the square root of 11.7? 11.7, right? And it's kind of nice if you think about it. What is the square root? It's a what power?
2.
No, square root is a what power? Square root is not a square. That's the exact opposite of square rooting.
The first though.
Square root of x would equal x to the 1/2. So I got half of 11.7 times another half of 11.7 makes a whole 11.7. Half of a y times another half of a y makes a whole y. Right? You guys see that?
So
1/3 of an a times 2/3 of an a makes a whole a. Hey. Yes.
This thing just with the fraction, right?
Yes. Good.
Okay.
I like it. Of course, you got to realize that.
It's not possible to give something and
Well, you just remember that
Okay.
I can always put something over 1.
Okay.
So on number 1, wouldn't it have been cube root a squared over cube root a to the 3rd, and then somehow, I don't know.
Oh, yeah. So that's the step I showed over there.
Right.
So this is the cube root of a cubed, but the cube root of a cubed is a.
But you wouldn't reduce the top at all somehow with that.
I can't. Why can't I reduce the top? Because it only has 2 a's in it.
Okay.
So there's no way you can totally eliminate the radical. It's going to be on top or the bottom. And normally we just don't like it on the bottom because then it's like double gross. Not only is it irrational, but you're dividing by it. Double gross. Right? So now it's only single gross.
It would be like, imagine the a was 8, so it would be 8 squared, and then on the bottom it would be 8 cubed, which would be completely different numbers, right? You get what I'm saying?
No.
I'm just overthinking.
Yes. That's what I think. I'm not sure what you're saying, but I think
No,
you're
I
over
get
here.
it in my head, but I can't explain it.
All right.
I do the math.
So here we go. Let's look at a little more interesting problem here.
No, like, she was.
Where we at, sir?
Oh, I was wondering how it magically was making around.
Oh yeah, that middle step there. Yeah, I showed it over there and then I skipped it over here. What you got, Jeff? I don't know. All right, let's not do too freakiness. Let's just start. Well, make that a B.
What are we trying to rationalize? Denominator or numerator?
So you just multiply the
Sorry? We're starting with the denominators. Yeah, that's what you normally rationalize. It's not until something like, now there are some problems in the I can't remember if I signed them, but there are some problems that say rationalize the numerator. You normally wouldn't have to do those kind of weird things until you hit like calculus. Normally we're just focused on the denominator. So what you ask yourself in this problem is, what do I have to give the bottom to make it doable? I've got to give it a couple B's, right? Good. It's completing the root. The root needs 5 things. I've only got 3, so I'm going to give it 2 more. Why am I allowed? Why is it legal for me to do that? Because there's a top and a bottom. So multiply top and bottom by 5th root of b squared. Give it the 2 b's. It's missing. Oh, it's kind of nice. So on the top, what do you get?
2 times b squared.
Yeah, why am I allowed to multiply those?
Because they got the same root.
Same root. On the bottom, I get 5th root of b to the 5th, which is just b. So you don't have to show this step if you don't want to. We designed it to come out nice, didn't we? That's the whole point. And the top is just this mess. You normally can't do anything with the top. Yes, sir.
Okay, and we can do another question like, but just different roots, or no?
Sure, yeah, hold on. Because so far I've been really nice. So far I've only put one thing in here. Right? Yes, sir. Totally. This is multiplying, right? So then you add the powers. Totally. Yeah. I'm just multiplying these across. Yeah. Cool. Okay. So here is the ugliest problem you would see. Let me make sure I'm telling you. Oh yeah. It's uglier than you'd see probably. What you got, Jeff?
Would this be the bonus problem on the test?
No, the bonus problem would be a lot more interesting.
Has been easier or harder?
A lot more interesting.
Are your bonus
Sit in there for
questions just like being easy, but like people would usually overthink their bonus questions? Is that what you do?
Normally bonus,
Do you
well,
just mess with us?
normally bonus questions, there's realization to make and then it's quick. But the realization is normally something that we're not used to. Sometimes I'll have a problem where it's just, like the problem in the last one. Remember where you had to do, I had 2 minus parentheses, 3 minus parentheses. That was sort of a longer problem. You just had to be patient and really organized. And a lot of people got the right answer of 8. Right, some people started multiplying. There was no multiplication in that problem, really, except on the very inside, if I remember right.
But the answer was 8 on that?
The answer was 8.
You didn't give me credit though.
I'm evil. You gotta show me. Yeah, don't let me, keep me honest. All right, so the way I'm about to say this is going to give it away. But do I have to give this thing 3 more 27s? No. Hell no. That's crazy. Because 27 is already 3 3s. Do you guys see that? Yeah. So if you can factor what's in there, you do it. So you don't have to give it 3 more 27s. Good God. I don't even want to think about what the number is. I can break 27 up, and now it needs only what?
1 more.
1 more 3.
So you want the top 2, right?
3 more A's. And 2 B's. Is everybody cool with that?
Yeah.
And whatever you did here, do the same thing there. So the mistake some people make is they try to do 2 different things. They're trying to do both of these. No, you can't multiply top and bottom by different things. If I'm rationalizing the denominator, it controls what I multiply by. Right? The top just gets all the crap just thrown together. So on the top, what are you going to get? 4th root? 21? A cubed, B squared, M squared, right? Just everything is slapped together.
Yeah, I didn't know where to put the end.
Doesn't matter. There's normally alphabetical order, but. And then what do I get on the bottom? 3AB?
Oh, no, it's
I would get 3 to the 4th, A to the 4th, B to the 4th, and the 4th root would just kill all those 4th powers. Do you guys see that?
Yeah.
We designed it so it would come out to be 3AB. Now the next mistake I see is somebody then cancels some B's and cancels some A's. Why can't I do that?
Because
Don't have the same root. The bottom doesn't even have a root, so you can't do that. That always sucks. I'm like, you do beautiful here, and then you go one word, I'm like, shit. They don't have the same root, so you stop. Yes, ma'am.
I have a question.
Sure.
Does it matter if you put 21 m squared that all the other variables have?
Oh, it doesn't matter. Like I said, normally alphabetical order, but you can just slap that on that and put the M first.
But I think in
Because I
math
noticed,
lab
like,
it does.
with foiling, I noticed a problem that if you place the variable in the wrong spot, it does knock off the problem. Like, that's, I noticed that's why I've been getting a lot of foiling wrong.
It shouldn't matter the order. Shouldn't matter.
But
I don't know if my.
No,
Math
you're
lab
saying like
does.
if it's like x minus 1, if you flip it so it's 1 minus x.
Well, that'll change it, of course, because x minus 1 does not equal 1 minus x, right?
Yeah,
Totally not.
totally.
But if I had x plus y times z plus m, that's the same thing as y plus x times m plus z. It's the same damn thing.
Yeah, because if I foiled it and I wrote like the 7x, like let's say there's where the underneath we have x minus 1 equals whatever, the second foiled problem where it has the 7
Or the
above
z?
your finger, above your finger, like there, if there was an m there and I foiled it, if I wrote 7xm or like 7mx, if I did that order, it messed up my foiling. That's what my question was. If I do.
Well, I think, I don't know, that shouldn't, unless you had like 7mx plus 4xm, and you didn't realize that those are like terms. Right? Those are like terms because they both have an m and they both have an x, right? And I don't know if my math lab really, is it really that picky?
Yeah.
You have to have an alphabetical order?
Yeah.
I think so.
That's
I
hilarious.
haven't noticed that.
It's very.
Even
I mean, to be honest, it's convention to have them in alphabetical order, sure, but it doesn't make it wrong, so that's another example of why I haven't made that mandatory.
I got wrong because I didn't put parentheses.
Well,
Yeah,
if parentheses
make
indicate
the
multiplication, then you have to
No,
have them
it,
there.
like it was just like on the top and then at the bottom it was like a single,
Single term.
like x minus 1, and just because I didn't put like the parentheses around it,
Yeah.
I marked it wrong, and I was just
You
like,
gotta shoot that question to me when that happens, because then I can see it. I can see what's.
I'll just
There's
read
a
it.
ask my instructor.
Yeah,
There's
there's a button.
and then it'll send me a shot of the problem. And then I can actually address the problem then. The one sucky thing about my math lab is it does not record your attempted answers.
Oh, it doesn't?
So I had a situation where on the WebAssign, the other thing I use in other classes, it does record the answer. I can see exactly what somebody tried. So if you got the first answer you put in was right, but it was picky, and then you put in a couple more answers, I can't see that first answer. I don't know if that was really right or not. Does that make sense?
I take pictures of
So you have to immediately take a picture or send it to me if you hit a problem spot where you think you're right and you think it's just being mean. Because they got some answers coded wrong in their course because it's made by humans. And that's what we do. We make mistakes.
So, would you accept doing my math lab on a paper and then turning it into,
No. And the reason that is because then your problems are completely different. And the only thing that makes it a little bit easier to get through all the homework that I have to grade is the fact that everybody's doing the same problem. So then I can grade it quickly. So if you give me my lab, it's totally different because all the numbers are different between my math lab people. So it's different from the book. That would drive me just a little crazy. You don't want to do that. Yeah.
For the same situation, you need to leave the solve as this one, or you need to change to exponential and do something.
No. This is here. Done.
Done.
Done. Okay. Whew. Blah, 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 blah.
Hippie break.
So that's all in section 12.4. Holy crap. Yeah, it's time for a break. I didn't realize it was that late. That's probably, is it going still?
Yeah, wow.